when you're ready.
Go for gold.
Okay. So this is where we are in Sandy Bay. We were at Front Beach, and Jasper used his binoculars to eye a piece of the breakwater which is submerged at high tide, but we were at mid tide, and so he was able to see it. And then he walked into the water until he could no longer see it, and then measured his height of his eyes above the water line, and that's this height right here. Here's Earth with its radius r, and he was a height above the water line, obviously not drawn to scale. The distance to that lump of land is d, and you can see that this is a right triangle with a 90-degree angle, and so this length is the hypotenuse, and that squared, r plus h squared, is equal to the sum of this little r, this r squared plus this d squared. That's your Pythagorean theorem. And you spread this baby out, open it up, and you have r squareds you can get rid of. You can move this h squared over to the other side, and then divide by 2h, and you end up getting a solution for the radius of Earth equaling the distance to the lump minus the height that his eyes were above the water line divided by 2 times the height. I worked with this map to figure out what this distance was, and it was around 2.96 kilometers. So let's do the calculation now for Jasper. This is going to be 2.98 times 10 cubed squared minus, what was it, 0.65? That was the height. It was near your waist. 2 times 0.65, and we'll see how close we get. 2.98 squared minus 0.65 x squared equals divided by 2 equals divided by 0.65, and you end up getting basically 6831 kilometers. It's basically 6.83 times 10 to the 6th meters, but that's what you got. The nominal equatorial, at least at the equator, is 6387. So let's see how close we got. Basically, 6831 divided by 6387. So he was good to 11%.
Hey!
On a very bad day.
And there you have it for physics in front of the facilities.
Yes, in front of the men's room and ladies' room at Front Beach.